All right, so again, parameter is from the population. Parameters from the population. Statistic is from a sample. Statistic is information from a sample. So what would be a good example about that? So if I said, hey, I want to figure out what the average age of the students are here at West Hills College, Lemoore. What's the average age of all the students that attend West Hills College, Lemoore? How can I figure that out? That'd be a hard problem. Yeah, I could estimate. Now, to really figure it out, I'd have to go to the administration office. They'd have to give me access to like the whole database, and I'd have to find the age of every student that goes to West Hills College or more, add them all up and divide by, to get the average, right? I'd have to actually access every single day. Big pain, I don't have access to that or a desire to spend that much time. But if I wanted to estimate, what I could do is I could just take all of you, for example. I could say, everybody tell me your ages, add them up and get an average. That would be a statistic from a sample. So a statistic, say the average age came out to be 32. Probably too high, huh? But there's a lot of people that are younger. So maybe, that's too high. Maybe let me say it's 26. Maybe the average comes out 26 of us. What if I just add up all the ages in here? And the average in Heron's stat class, the average age is 26. So I go, okay, so I think 26 is close to the average age for the whole school, because it was the average age in my class. So maybe that's the average age for the whole school. Well, there's probably some problems with that kind of conclusion, which we can talk about for a minute. But does everybody get the big idea? You're trying to figure out something about a whole population, a parameter. So my goal is to figure out the parameter. What would the parameter be in that case? It's the actual average age of the whole school. Does that make sense? So parameter is a fact from the whole population, and statistic is a fact from a limited group, taken out of that whole population. So we use statistics to decide things about parameters. Make sense? So if our average age is 26 in here, and I'm saying, so I think the average age of the whole school is probably close to 26. Well, somebody could come along and say, that's not very good statistics work. So our goal in here is to learn to be good statistics workers. Can you offer some critiques? Why would that be a bad way to try to get to the truth of what the overall average age is at the school?
Sample kind of small.
Samples might be kind of small, just 35 or whatever we are, people. That could be. What's that?
The type of class.
Yeah, type of class. Yeah. What do you mean by type of class?
Like, depending on what majors people are going into.
Yeah, might be different, huh? If you're, stats might be a lot of nursing majors, or some group that might tend to be older or younger. Also, how about what time we're taking this class? Night classes, are that more younger or older? Yeah, usually people that have jobs, and a lot of times they're older, huh? They're coming to night class. So really, it's for several reasons, that's not a good way to poll. That'd be just like trying to figure out who's going to win the election by only going out and asking rich people or poor people or a certain race, right? You already have the feel that to get a good poll, you've got to kind of mix it around, don't you? Yeah, and we'll talk more about that tonight. But I want to just first off lay out the basic idea. Statistic is from a sample, from a little group, in order to determine something about the whole population. All right, quantitative data. That's numbers. So we could, like I was just doing average age. That's a number, isn't it? If I wanted to say most common race, or most common gender, is there more men or more women at West Hills College, Lemoore? That would be data that's not numbers, not quantitative. That would be categorical data. So we have two kinds of data. You tracking with me? Let me go back. Quantitative data, numbers, and then categorical data like your gender, your race, your whatever, where you live, city, country, all those other kind of things. So two kinds of data. Numbers, categorical, numbers, quantitative, and then not numbers, categorical. Qualitative, or it's an attribute. You don't need to write all those words down. Like I said, you'll have all this. This is already on the Canvas website. Just think with me on things so we can keep moving and not have to write a million things. I love this, by the way. I taught stats 15 years ago. I wrote all this stuff on the board, and my poor students wrote it all down on their papers. So this is, I'm glad for technology. All right, working with quantitative data. There's two kinds of number data. Discrete numbers and continuous numbers. You know the difference between those? Discrete numbers and continuous numbers? You can jump over and see. Discrete data, their definition doesn't seem very clear to me. It's when the data values are quantitative and the number of values is finite or countable. They're using a big fancy math word that probably doesn't make a lot of sense. Basically, a nice way to say that, if I said, what are, how big, maybe, do they give an example? Let me see if they give, no, there's the homework. We're almost to the homework. Okay. So I guess I'm going to have to make up, here, good. Let's go to continuous. That'll be the best way to understand discrete. Look at continuous data with me. Continuous data is when numbers can be anything in between, including decimals and anything. Like if they said distances. If I said, how far is it, how wide is this room, for example? Well, I don't know. How wide is this room? Maybe, what is it? 20 feet? Maybe 20 feet wide? Is that right? No, maybe 25 feet? Higher? 30 feet? You guys probably have a better eye than me. So maybe 30 feet wide. All right. Now, it's not exactly 30, is it? It might be 29.8763. I don't know. Oh, they're talking centimeters. I'm talking feet. But anyway, my point is, it doesn't have to only be whole numbers. It's continuous. It's smooth. Get the idea? Like a clock. How about? I think maybe one of the best ways is to think about a clock. What about a clock with a second hand that moves smoothly? Instead of jumping, tick 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 tick. That's a discrete clock. A clock where the second hand moves smoothly. Smooth movement. Smooth movement is continuous. Whereas discrete would be like watches that show, second by second by second. There's definite breaks. There's not a smooth move between 5 minutes and 33 seconds and 5 minutes and 34 seconds. It just jumps. In reality, there's all kinds of hundreds of seconds in there, but if it doesn't show that, if you have a watch that just goes 5:33, 5:34, 5:35, as opposed to a clock where the hand smoothly moves along, that's the difference. Continuous moves smoothly, discrete, jump, 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 jump from state to state to state. All right, so we're just saying, what are all the different kinds of data that we're going to run into? Let's jump into the homework. This is where I'm afraid you're not going to be able to see that. I can make it a little bigger if I go back to something else, but not there, huh? Yeah, that does nothing. All right, now, can you read that? Can you read number 1 there at all? It's kind of small, huh? Okay. So, there we go. So, determine whether the given value is a statistic or a parameter. Again, I don't want you to have to write all the options down, all this crazy stuff. You'll have it all. It's all in Canvas. You can grab it anytime. Let's just think about it together. So how do you know whether the given value is... Wait, what? Am I in the right number? Oh, yeah. Sorry. It was just looking funny on my screen. Okay. It's all good. So is it a statistic or a parameter? Of all 1571 students at college, 35% own a computer. So that 35%... is that a number from the whole college or just from a small part? Did they just take Heron's class and ask what percentage of Heron's class own a computer? Or was it the whole college? The whole college. So the whole college. So it was the whole population, huh? So that makes what? Is 35% a parameter or a statistic? Parameter, yeah. PP goes together and SS goes together, right? Parameter with population, P with P, and S with S. So, yeah, that's a parameter because it's from the whole population. If they just said, in Heron's class, he surveyed and 35% owned a computer, well, that would just be a statistic because it's from a smaller group, right? So, it's a parameter. Now, there's 2 parameter answers. Which one's right? Because the value is a numerical measurement describing a characteristic of a sample? No, it must be this one. Parameter because numerical describing characteristic of the population. Yeah, parameter PP, parameter with population. Good? So far, so good? So same thing. Oh no, they're saying qualitative or quantitative. So remember what that is. Quantity means number, huh? So whenever you see quantity, and you get a 3x5 card, you can write these definitions down in a 3x5 card for the exam. Every exam you get to use 3x5 card, write whatever you want, front and back, 3x5 card. So quantitative means numbers, quality, not numbers. Okay, so here we go. Area codes. So what is that? Yeah, quantity. So it's one of these two. Because they consist of counts, because they don't measure a count. No. It's C, huh? On my option. Does that make sense? See what I'm doing there? All right. So I'll move on to number 3. Can you see number 3 down there okay? State whether it's discrete or continuous. The number of car accidents in a given stretch of highway each year. Yeah, because that's a fixed whole number. You can't have like 2.3, right? Get the idea? You can't have, it's not continuous. You're either going to have 2 accidents or 3 accidents. You can't do any of the numbers between 2 and 3. Makes sense? That's the difference between continuous and discrete. So that one would be discrete. Is it this one? Is it A? Discrete because they can take on any value? No, they can't take on any value. Discrete because the data can only take specific values. Yeah. This making sense? Good? All right, sir. Determine whether the given value is a stat or parameter. Homeowner measures the voltage supplied to his home on 25 days of a given month, and the average mean value is mean means average is 121.7 volts. Is that a statistic or a parameter? So you want to think, is that measuring everything or just a small part of everything? So what did he do? He measured, did he measure every day?
No.
Just 25 days in a month. He's trying to get a feel of what his average voltage usage is, but he's not doing every day of the whole year, is he? He's only doing a small part. He's sampling. He just dipped in and grabbed a sample. He didn't do everything. So that's going to be a statistic, right? S goes with S. Statistic comes from sample. Which one is it, though?
C.
Oh, yeah. Statistic, sample. Yeah. Not population. Good?
I did the given value is the statistic for a week because the data collected represent a sample, and it told me it was wrong.
Uh-oh. Let's see. A particular country has 40 total states. If the area of 25 areas of 25 states are added and the sum is divided by 25, the result is 183,877 square kilometers. Determine whether this result is a statistic or a parameter. Basically, did they do all of them or part of them?
Part of one.
Yeah, there's 40 total states. They did 25. We don't need all the rest of the blah, blah, blah. They just didn't do them all. So it's a statistic from a sample. Yeah. So statistic from a sample. Yeah, B. That's good? This making sense? Mm-hmm. All right, 6. State whether the data described are discrete or continuous. The weights in tons of the trees in a forest. So the difference between discrete and continuous, it's like the clock. Think about the clock. Continuous is smooth. It can be any numbers. And discrete would be just boom, boom, boom. So answer this question. Ask yourself this question. If I said, and what are we measuring? The weights of trees. So if I said, hey, how much did that tree weigh? Somebody said 67.3 pounds. Yeah, it could be anything.
Another one.
The next one could be 67.289 pounds. Huh. No, that's continuous. That's not jumping. It doesn't have to jump from one thing to the next. It could be anywhere in between.
Continuous again.
Continuous again. This is continuous. This answer should be continuous because continuous is smooth. Like a clock, right? A clock that second hand moves smoothly, you could stop it anywhere. Anywhere. It's not limited to 60 positions as it goes around. See the difference? With tree weights, we're not limited. There's, if I was to say to you, well, how many different tree weights are possible? Well, infinite. But even, of course, that probably didn't help the thing. What if I said, hey, how many trees weigh between 10 and 12 tons? Well, it's not just 3. It's not just 10 tons, 11 tons, or 12 tons. That's not right. It could be 10.3 or 11.5. There's actually infinite values even just between 10 and 11, aren't there? That's continuous. See that? That's continuous. I don't know. There's probably 2 continuous. They always give 2, don't they? Continuous, because the data can only take on specific values? No. Any value. Continuous is any value. That making sense?
Yes.
All right. That's probably the weirdest thing we're looking at is that continuous discrete thing. What are we talking about here? So we're doing discrete and continuous. Number of people that drive by a certain billboard each day.
Discrete.
So can that be like any numbers?
No.
Or is it limited to certain numbers? Certain numbers. It's got to be a whole number. You can't do 3.2 people. Yeah. So it's discrete because it can only take on specific values. Good?
Yes.
Number 8, determine whether the value given below is discrete or continuous. The volume of a cola in a can.
Continuous.
That could be any amount. They say it's 12 ounces, but it's not exactly 12 ounces, right? It's 11 point or 12 point. It's not right on the money 12, just because they say it is. In actuality, it's, a little off one way or the other. And it can be anything, right? It's continuous. Because there are infinitely many possible values. Continuous, yeah, it is B there. It is B because it could be infinite values. Is that good? Number 9. Determine whether the value is from a discrete or continuous data set. Time to learn a song.
Continuous.
Yeah, could that time, is that time limited to certain values or could it be any? It can be anything. That's continuous. Actual time is continuous. Right? Number 10, state whether the data... Well, I better get a new screen for that. All right, number 12. Which of the following... I'm skipping around a little bit here. Which of the following consists of discrete data? Number of suitcases, amount of rainfall, tree height, hair color. Which of those is limited to certain numbers? Because that's what discrete means, right?
Number of suitcases on the plane.
Number of suitcases. Right? You can't have 5.7 suitcases. Whereas rainfall, that could be anything. It could be any number. Tree heights can be anything. Hair color, that's not even a number. That's categorical data, right? That's not number data. All right, number 13. Which of the following is categorical?
Hair color.
Yeah, we just did that, huh? Hair color. Right. All right.